Okay, welcome back. In this lecture, I want to talk about stateless and stateful lambdas. Now, I've seen stateless and stateful functors before, and as we'll see behind the scenes, the compiler is basically going to generate a functor, and so lambdas are basically implemented behind the scenes using functors. A stateless lambda does not capture. As we've seen, we can have the empty capture clause, where we do not capture anything. But if you want to pass data as arguments to the lambda, then of course we can still have parameters. That can be applied in both cases, whether you have a stateless or a stateful lambda. Now, a stateful lambda is going to capture. In other words, we are going to have a captured variable in the capture clause. In the example, we are going to capture the variable v. So we pass that v in the capture clause, and then we can go and print that out or something like that. We have seen examples of stateless and stateful lambdas before, but just to reiterate, in this example, I have two variables, x initialized to 3, y initialized to 5, and then I have a stateless lambda. So it does not capture anything, but that doesn't mean that we cannot have formal parameters. So I have a formal parameter x, which is going to accept some integer, and then we simply print that out, and I pass in 55 here. You can think for a second what the output is going to be with this, because we have a formal parameter x, but we also have x at the outside scope here. I'll just build around this quickly, and we'll see we actually get 55 for that first one right there. And that's because I pass in 55, where I actually invoke this inline. So the parameter is x, don't get that confused with the outside variables, okay, from the outside scope. But of course I can also pass in x, and then that should print out 3, we'll see that in a second. Moving on, we also have a stateful lambda, which I've assigned an identifier, and that does capture, it captures x and y. And it's going to print out the parameters, so I'm going to pass in two variables, parameter 1, parameter 2. Down here I can pass in 1 or 2, or I can pass in those variables. But basically this is going to print out the parameters and also the captured values. But remember, I'm now passing in 1 and 2, so I'm invoking that using the function call operator, pass in 1 and 2. And if I build a run, we get the parameters are 1 and 2, those are what we pass in as arguments, and it captures the variables from the outside scope, 3 and 5. And as I mentioned, we'll get 3 now for that stateless lambda up here, because I pass in x. Again, just highlighting the difference, a stateless does not capture, whereas a stateful will capture from the outside scope. And then also I'd like to mention that of course these formal parameters do not have to be value parameters, we can also have a reference. It'll work, I'll just build a run, you'll see that works fine. And also const should work fine as well. And then you can invoke it maybe with a literal when it is const. Of course, you'll get an error if it's not const. Build a run, and that should work fine as well. So that again is the formal parameter. Do not get formal parameters confused with what we capture. For this lecture, I want to use a tool called C++ Insights, which can be located at cppinsights.io. Basically what this tool does is it's going to visualize or make visible what happens behind the scenes when we do things such as declare a lambda and so on. So it's a really handy tool, you can play around with it for a bit. And with this tool I want to demonstrate a few things to you which will hopefully make it easier for you to understand lambdas. Okay, I'm at the website cppinsights.io, and I have this program here. I include the IO stream using namespace standard at the top here. And then I have the main function. I have two variables x and y which we'll use a bit later, but then I have the lambda right here. The identifier is lambda here. You can just call it L as well if you want, or whatever you want, but for this demonstration I'll just call it lambda for readability here, so it's easy to find and to see what's going on. As we can see, the capture clause or the capture list is empty, so this does not currently capture anything, but it does have two parameters, p1 and p2, and I'm going to print those out. End that off here with a semicolon as well. Then I invoke that, so I have lambda, the parentheses, I pass in 1 and 2. Then I do a console output statement again, end of program, and so on. We're not concerned overly with that. We just want to see what happens behind the scenes when we compile this, and the insights will be generated to the right here, to this right column. Now what we can do is we can click this run button right here to generate the insights. Of course you can choose the standard right here, you can choose the font size and so on. But for right now I'll just click on run C++ insights. And to the right it's going to generate this for us. You can see it's pretty much the same up until here. But notice what we get here. The compiler is actually going to generate a class called a closure behind the scenes. You can see it has a funny name with a bunch of underscores and numbers and so on. we have the function call operator right here. The formal parameters are going to be P1 and P2 as we have it in our actual code to the left here. This is going to be const. We will talk about const a bit more as we go along. Alright, so I'll scroll down. We're not concerned with the entire implementation, I just want to show that this generates a class behind the scenes, and that is how it implements the Lambda. So this is where the end of the Lambda definition is, or that class definition is. Then notice what we do here. We called our Lambda right here, and the return type is auto, so we use auto type deduction for that. But notice what the type is going to be for what is generated by the compiler. It's going to match the class identifier or name right here. Okay, and then we assign it. In this way, we're going to construct an instance of that, so we're going to instantiate that. And so that is basically what we are doing here. We are basically instantiating Lambda, and it's going to be the type of a generated class, which is going to be generated behind the scenes when we compile, and that is where we have to use auto right here. Because as we are programming, that class, of course, has not been generated yet. Okay, so during compilation, it's going to generate that class, and then it's going to instantiate Lambda, as we can see here. It's going to instantiate that of that particular type. Okay, and here we go and use the constructor. And on line 14 here, where we invoke that particular Lambda, of course, we are going to use the function call operator. So it does lambda.operator, and we pass in those same arguments. You can see everything matches here. And then, of course, I still do that console output right here and so on. But this is basically what happens behind the scenes. Now this is currently a stateless Lambda that gets generated. Now what happens if you want to generate one with a capture list? How is that going to translate? You can stop the video for a second and think about that. So for example, if I go back and I pass in X and Y, or just one or the other, it really doesn't matter. And I'll just copy this. Okay, so this Lambda will now print out the parameters that we pass in, and it will also print out the captured values. As I mentioned before, we cannot print it out in this way without actually capturing those values. Otherwise, we'll get an error. But okay, now that we are capturing those, if I go and run this again to generate those insights, it will generate some Lambda class again. We have the function call operator implemented right here. It's going to take in where it has its formal parameters P1 and P2 as we have it here with our definition of the Lambda right there. But notice the difference. Now in the private section, we have two variables called X and Y, which is what we pass in to the left here. Okay, so it's going to capture those variables. And it has to do that in some way. Now, don't get confused with the variables that we define in the outer scope within main. Okay, those we do right here and up here. This is within a class definition within the private section. We now have X and Y. So this is referred to as a stateful Lambda because it captures those variables. Then we also have this constructor right now, and in the initialization list, it's going to initialize those private members. Once more, we go and instantiate that class. So we go into instantiate that, call that Lambda. This is basically what we are doing here. But during compilation, again, it first will have to go and generate that class before we can do that assignment of the type. So that is what we get here. We go and invoke that constructor right here in the public section. Before we did not take in any arguments. Now we pass in X and Y, which is up here. So again, don't get confused with the members and what we have at the top. That is from the outside scope. So we have X and Y, and then we go and invoke that. We pass in those two arguments, 1 and 2. Notice the difference. When we construct it, we are going to pass in the values from the outer scope. But when we invoke it, or in other words, when we use the overloaded function call operator, we pass in those two arguments. So capturing a value, we pass that in with the constructor. But the arguments for the function invocation, of course, we pass that in, and those will get accepted by the overloaded function call operator. Okay, let's go back and make a few changes. So let's say we go and capture X and Y by reference now. Or actually, I'll just capture X by reference and I'll leave Y. And then I go and click that play button again so we can generate the insights. Now what we can see in the private section is we now get a reference to an integer right here, whereas Y is a copy. I also talked about mutable before. So for example, if we try and make a change to Y in here, then of course we'll get an error. And to change that, we want to make this mutable. Now let's see why that is. You can think about why that is for a second. Okay, so let's look at the class definition for a second, and we can see the overloaded function call operator here takes in those two parameters, but it is const. Okay, so let's go and change that. If I now change the Lambda definition, to mutable and I go and run that insights again, notice that const just fell away. Okay, so the overloaded function call operator is no longer const. And of course, if this were to return something, so I'll just go and make a change. Okay, something like this is going to return the sum of p1 and p2, which are both integers. Go and remove that, so we are capturing by value here. It doesn't really matter that much, but I'll just capture by value. And I'll go and run again. This overloaded function call operator is now going to return that as well. Okay, it's going to return int, but we can go and be explicit about the type that we want to return. So we specify that to return double, and I can run that again. And it's now going to return double. And it's actually going to do the static cast and everything. So you can see both mutable and the trailing return type is going to be optional for us. But I just wanted to show you a basic idea of what's going on behind the scenes and how the Lambda works. As you can see, it's basically going to generate a functor. Again, a functor is going to be a class or a struct with an overloaded function call operator, and it can have a state or it can be stateless. And as we've seen, it's going to be stateful when we capture values. So we are capturing x and y right here in the capture clause. This is a handy tool to see how things are generated behind the scenes and also to give you some ideas of how to go about defining your own classes and such. Now at this point we have discussed functors and stateful and stateless functors, and where those can be useful it depends on what you have to pass in, and if you want to sort of manipulate that from a unary operation to a binary operation, for example, then you can use a stateful lambda or a functor to do that. And actually I have one more example on this. I'll change either one of these or both of those to auto. So for the parameters in the lambda definition, I'll change those to auto. And if I generate the insights now, you will notice this will change to a template. That is, the function call operator is now a template, and those types are passed in here for the types of the parameters. Next, I'd like to demonstrate the fact that we can convert a lambda to a function pointer, but only in the case where the lambda does not capture. We have seen a demonstration like this before. I have a print scores function which is going to take in an array. We have a size parameter, so we're going to pass in the size of the array. Then we have a function pointer, so in this case, for this example, we are simply going to display all of the elements within the array. So we print out the scores are, and then within a for loop, we are going to invoke the callable. Okay, so we pass in the array parameter and we pass in that index starting at 0. So I have this display function, and then in the main function, I have a constant array size, and then I have an array scores with some predefined elements in there as well. And then I have a print scores invocation. I pass in the scores array the size of the array, and now I'm passing in this lambda right here. You can pass in the display function that we have defined up here. That's going to do a console output. It's going to print out the parameter that it takes in, and that is what we invoke right here. Okay, if you invoke this, okay, we pass that function in, we have a function pointer to that, and then we invoke that function indirectly. We pass in what to print out by fetching that, passing in the index, and then we simply do a console output within that and a tab as well. So that is how that will work. I'll just pull the run. Prints out those scores. Simple enough. I'll just go and undo a few times so we get my lambda back, and you can see I have a simple lambda that's going to do the same thing as we have in that display function up there. Going to print out those scores. So with this we can see that the lambda can be converted to a function pointer, but I would like to note if you capture something. So let's say we capture some variable such as the array size, and I try and build this. You will get an error. Cannot convert from the generated lambda, which is a functor again that's generated at compile time. You can see it has those weird numbers that we've seen previously, to the function pointer. And that is because no user-defined conversion operator available that can perform the conversion, or the operator cannot be called. So that was just what I wanted to demonstrate with that, is that we can convert a lambda to a function pointer, but only in the case where the lambda does not capture. That is one limitation that you will have with the lambda, but you can solve that with the standard function, as we'll see in the next couple of lectures. In the next demonstration, I'll be using a predicate. Now, a predicate is a callable that returns a boolean. So in other words, if you have a function that is going to return a boolean, and of course in the case of a functor, you will have a bool operator, a function call operator as a member, And in the case of a lambda, you will return something that evaluates to a boolean true or false. Now that we have an understanding of what a predicate is, I want to modify this print scores function so that it will accept predicates. I'll do an underscore if so that we can know that, okay, this is going to do some display or whatever it does based on a condition. And then I want to modify this. This is going to be function pointer to some predicate function. Because it is a predicate, then it has to return a bool, and it's going to take in an int. That's fine because we have an int array right here as well. Okay, now when defining a function like this, you want to think about what you want to do. So let's just go down to the print scores function here, print scores underscore if, and then I want to go and make a modification to the lambda. And I want to display all of the even numbers within that array. So what I can do is I'll go and modify this. Use the modulus operator, the parameter modulus and 2. If that is equal to 0 or the same as 0, then of course we want to return true. And so with that we want to display all of the even numbers within the array. So let me go and modify this for statement right here. Instead of using a display function to do the printouts, we're going to do that within the actual print scores function, of course. But we want to do a test, so if. So this predicate is now going to take in an int. What is that int going to be? Well, it's going to be the element within the array that is going to operate on. If that predicate returns true, in this case, it's going to do this calculation that we have defined right here. The parameter modulus 2 is equal to 0. Then, what do I want to do? I want to print out that element. And that should be all that we need for this. Again, making sure this lambda does not capture anything. And of course, you can do the same thing with a function and pass that in. But this is really handy with lambdas to define a quick calculation that you want to do without having to go and define a special function for that. So I'll just pull the run. And we get the scores are 72 and 68. And what I want to do is just add a tab at the end. But of course, you can define your own output. I just do it in this way because if you have it from the top down, like in a column and you have many elements in the array, then of course you'll have a long list here. And also the spacing may be too much for you, so you may want to add a single character space instead of the tab. So you can do this. You can do that. But I'm just going to stick with the tab. Okay, now as an exercise, I'd like you to go and invoke the print scores functions again. But in this case, I wanted to define a lambda that is going to display the odd numbers. And that is what we'll do when I come back. Okay, I'm back, so let's go and define. I'll just copy that. We'll define a lambda that is going to display the odds. So simple change, we are still using the modulus of, so the parameter modulus of 2. Modulus again returning the remainder is not equal to 0. To make the output easier to read, you can do something like this. The evens are, the odds are, and pull the run to see what we get. The evens are, the odds are 51. Alright, so this is where lambdas are handy, and that is with predicates. And as I also demonstrated, we can convert a lambda to a function pointer as long as it is stateless. And with that, we are going to wrap up this lecture.